Extraneous variables are relevant to the area under study, but are not the focus of the study. They cannot be ignored because they can influence the outcome of the investigation. When studying the effects of social support on the length of hospital stay following the birth of a healthy child, possible extraneous variables include marital status, age, cultural background, and number of previous deliveries. Women who are either very young or older in terms of having babies have lots more medical problems. That's going to affect the length of their hospital stay, and it's going to confound the results of this study. If her cultural background says that you take on a sick role after having a baby, that's going to affect the length of time she stays. The same thing with a number of previous deliveries. It could make her length of stay shorter because she knows what to expect, but it also could make her length of stay longer. If she's had 13 babies, this 14th one is probably going to have some more complications, like hemorrhage. Extraneous variables can affect the situation, so you can't be sure if it's the dependent variable or the extraneous variable that's causing the results you're seeing in your experiment. What can we do about it? How can we minimize the confounding or detrimental effects, the confusing effects of these extraneous variables? Well, one of the things we can do is use randomization. By randomizing a sample, you are more likely to get a sample that truly reflects the population. And in that case, you won't get a disproportional number of very young mothers, or a disproportional number of mothers who have never had children before, or a disproportional number of mothers from a specific cultural background. And in that way, you can help to lessen the amount of some of these confounding factors. You can also use what's called homogeneity. That means you pick a sample where everyone is the same. You choose which one of these extraneous variables, or which ones, if you're able to do this for more than one at a time, and you make everybody in the sample have that factor. For instance, maybe you want to, maybe if you think being a Cuban American makes a difference and would affect the results, then you pick a population that's all Cuban Americans. Or you can pick all teen mothers, or you can pick all mothers who this is their first baby, something like that. That will help to minimize the effect of these variables. Because the next time around, when you do another study, then you pick a different group. Matching is another technique. It's a little more complicated. It means if you think marital status makes a difference, then you make sure you have the same number of married women in each group. If you're doing an experimental study. If you're doing an experimental study and you think age makes a difference, you make sure the age of the two samples is about the same. If you have a 16-year-old single mom in one, you have a 16-year-old single mom in the second group. There are ways of using statistics to try and tease out how much are these extraneous variables messing with your results. And a technique is called analysis of covariance. If you think these extraneous variables truly do influence the outcome, then put them in your research question. Formalize it. Make them one of your independent variables. Finally, let's have one more example. Here's a hypothesis. Prenatal nutrition classes have a positive effect on the dietary habits of mothers after delivery. Well, one of the extraneous variables would be the type of delivery. Having an unplanned cesarean puts an additional burden on women's nutritional status, and she may be too tired to spend much time on nutritional concerns.